All right, guys, welcome back. This is our process capability and process capability index lesson. So in this, we talk about how we can use it to understand is our are we in specs or out of specs, and then essentially that's what CP and CPK is telling us. Where one tells us if we're centered, and the other one tells us about the process and how we're deviating to the left or right. So in CPK, what's really cool about it, let me find my mouse. So process consistency and process capability, right? When we look at our target range, we're trying to say our LSL and USL are two separate entities, right? Well, oftentimes when we have errors or mistakes, and when it starts to cluster up and we have a lot of those, we can sometimes see by the data on where we're shifted towards. If we're going towards more of the lower specification limit or that upper specification limit. So it's kind of like looking at this car, right? Now, as we've been talking, we've really only said that one, we've looked at a normal distribution as one, right? Theoretically, in Six Sigma, your process should fit into specs how many times? Well, three times. Three times. And you can see that by the designated curves here, right? So we have our LSL, we have our mean, and we have our USL, right? We adjust for 1.5 sigma because that brings it over to it centers the process, right? So when we look at the LSL and mean, we're looking at one side of the curve versus if we're looking at the other side from mean to USL. So we typically say there's 3 standard deviations, and that's how much your process should fit into specs. So basically, the voice of the process is that LSL, right? And this is how it fits into specs, right? How does your process fit into specs? And that's what we're trying to identify with process capability, right? The capability analysis is to overlay that voice of the customer with the voice of the process, right? And merging those two to be able to create a sustainable and great product for your customer. So when we talk about tolerance, right? Now, tolerance is essentially you're looking at the space and maybe essentially that spread of the data, how spread out it is, and that can be understanding as tolerance, right? So if you look at it from that standpoint, we have our LSL, and then we have our USL, right? Anything in between is going to be our tolerance, right? Well, who dictates that tolerance level? Well, oftentimes it is the customer. So I want you guys to write down this formula. It's CP equals the USL minus LSL divided by 6 times the standard deviation. Now, I want you to go ahead and write this out. We're going to do the first part of this handwritten, and then we'll move over to Excel. So we use process capability when the process is centered. Now, oftentimes we don't know, so this becomes like a trial and error thing. We go through it, and it tells us if our process is centered. Now, why do we say 6 here? 6 times, well, 3 standard deviations on the right and 3 on the left. So what we're basically saying is how many times will this process go into specs? Now, your process should fit at least once into the specs. Okay, if it doesn't, you don't have a good process to begin with. Go ahead and pack it up, and send it on home because it ain't working. So CP deals with process capability and understanding of the process is centered, right? So I want you to I keep saying it, but when the process is centered, we use process capability. I want you guys to help me out with this formula, right? I want you to write through and solve through it until you get this 0.83. So we produce a part with a mean diameter of 2 inches with a standard deviation of 0.03. We have a lower and upper specification limit, which are 1.9 and 2.05. Now, if you notice something special about our tolerance, we can already tell by looking at the data, our lower and upper specification limits, it's not a centered process. So, and it indicates that through the data. So I want you to take a couple minutes and I want you to solve through this equation and then we'll come right back. So essentially when we look at this, we get 0.83 and then we get that the process is not centered because it's less than 1. Just always remember you need to at least have 1 to have a okay process. Now, what do we do when the process is not centered? Well, we use process capability index, right? CPK. Essentially, you have your USL minus mu divided by 3 times sigma on the upper side of the spectrum, and then you have mu minus LSL divided by 3 times sigma. Now here, we're using 3 because we're looking at which side of the curve is our data most heavy on, right? Where that variation indicates for us. Now, when we go back to this formula, you notice there was a value we didn't use in the CP, and it was that 2 inches diameter as the mean. So now I want you to add that into your equation. You should have 2 theoretical answers here, one on the lower side and one on a higher side. So I want you guys to go ahead and take a couple minutes and I want you to solve through this equation. So as you guys go through and get that answer, you get 0.56 and then 1.11, right? Maybe a run-on number for 1.111111, right? It just keeps repeating. Now, in process capability index, CPK, what we will look at doing is only utilizing that smallest value, the minimum number. So in this occasion, it would be 0.56. When you guys go through that and you go to the statistical table, that sigma level conversion table, you can identify your sigma level and compare it to the defect rate. Now, here's the cool thing here. If you notice, we have a value of 5 points, I'm sorry, 0.556 maybe, right? All you have to do is multiply that value by 3 to get your sigma level. So let's go ahead and do that. So when we do that, we have a sigma value of 1.668. So we are somewhere in between these margins, right? Now, the cool thing is once you understand process capability index, you can understand the sigma level. When you understand the sigma level, you can understand what defect rates you typically would have at that sigma level. So what I want you guys to look at now is I want you to look at building this in Excel, right? So process capability, CP and CPK, and understanding how to input it into Excel and get the data extraction that you need, right? So I'm going to go ahead and pause the video, and I want you guys to go ahead and build out this formula into Excel. Now what I want you guys to do is I want you to consider an oil change. Service aiming for a completion time between 25 minutes to 40 minutes. The process has a mean completion time of 30 minutes and a standard deviation of 5 minutes. I want you to calculate CPK, telling me which is the true CPK, the lower value out of those two numbers. So I'm going to go ahead and start building this in our formula. So we have our CPK, right? I typically like to do it in this format. So you have CP, we have our mean, we have our UCL, our LCL, and then we have our sigma value. Now, as we go into this, we say 5 minutes for sigma, right, our standard deviation. Our lower control limit is 25 minutes. Our UCL is going to be 40 minutes. And our mean time is going to be what? 30, right? So as you're building this, right, I usually do the CP formula first. So our CP formula, so as you go through this, we'll hit enter
I
there.
did 3.
Ooh.
Because for this, it should be 3, correct? If we're doing CPK?
Yeah. Well, let me look at CPK now.
Oh, you were doing CP, okay.
Yeah. So CPK, I have the same variables, right? Let me put that form of text right there for you guys. So CPK USL, CPK LSL. Okay. So when we look at this equals, it is our USL minus the mean, or yeah, minus the mean divided by 3 times the sigma value. Okay. This is going to be the mean minus the LCL. I said USL, LCL right here. Let me fix that real fast. Divided by 3 times the standard deviation or sigma value. Now, which one do I choose, Zach? Well, CPK is always going to be the lesser value. An easy shortcut I want to teach you is going to be lowest value, or we'll call it CPK truest, or true. This is going to be MIN, minimum, and highlight these two values. Now, obviously we can see it, but when you start looking at a lot of data as a whole, it's good to build out this spreadsheet. So through here, we learn how to calculate CP and CPK in our formula in Excel. Now, a few things I want you to remember. Capability analysis is to overlay the voice of the process and the voice of the customer. It lets us know where our data is clustered and where we could potentially not be a centered process. And so when we have a centered process, we're going to use process capability, CP. When we have process capability index, we're going to use both of these formulas and choose the smaller value out of both of them. That's going to let us know where the smallest, like where our data is kind of clustered highest, and maybe where we should readjust our data.